Hi everyone and welcome back to Pardeslines. Today I want you to understand why the point cloud is the future of AI. First of all, let's discuss about companies like Tesla and Mobileye that are currently using LiDAR and other systems, other sensors to detect the distance from a car to another one in order to get autonomous driving. So this is a new model of Tesla, and this new model is currently using this kind of technology. Let's see with this video how it's working in real time. You can see in the screen here the distance between this car and the other one. We can see also that we have the information, all the things that we currently see here in 2D, we have the information in 3D in this screen. How it's possible? I mean, even we have some modelization of the depth, okay, in real time. How it's possible to get the 3D information, the 3D perception in real time? In fact, LiDAR is shooting millions of laser beams every second in order to get the 3D perception. So let's now see how we're going to work today. So we need first to download the Open3D but especially from now we need to work with Linux instead of working with Windows. So let's see that together now, and let's go ahead. So I added in my Pardeslines repo two modules, one for visualization of the LiDAR car and one other for the camera visualization. So we will have also the temporal visualization. So what I want to do with you first is to install the things using Ubuntu. So you need first, if you are working with Windows, we need to install WSL. WSL is installing the dependencies in Linux inside your laptop, and then you will be able to have, for example, the Ubuntu. When you have installed WSL, you need also to install the dependency of Ubuntu, and then you can open the Ubuntu, for example. So let's open it. When you open Ubuntu, you can do like that, code and then dot, and this will install in fact the VS Code, because the VS Code in Linux. Then when we have that, you can already also install the Anaconda under Linux, and then install the different dependency and requirements for working with Open3D. So this is exactly what I did. I also added for you a requirement for WSL and Open3D. So all the things you need to do is to first to install WSL, to install Ubuntu, and then to connect to Ubuntu using this point here. Okay, connect to WSL. And when you are connected to WSL, you just need to get your folder. So let's do that together. Open folder and then go to in my case it would be MNT C code, and then here Open3D. So I have the repo and also Pardeslines, and so I can now open it. So now this is the Pardeslines repo opened using WSL and Ubuntu, and I have also already installed also the dependencies and the Anaconda environment, so I don't need to do it again. I just need to do conda activate Open3D. When Open3D is my own environment, and then I can from here execute my code. So what you need to do again, let's see that together. You need to install, after installing Ubuntu, and after you get this window, you can create your new environment with Python 3.8, and then to activate it, and then install the different things here. So be aware that we have several ways, in fact, to install the requirements of Open3D, but because it's a previous repo, it's not working well if you just install the current dependencies which are written in the Open3D repo. So I suggest you to do that. Okay, I get inspired by Cloud Code also to get the requirements as well. And it's currently working for me, so I guess it will work for you if you are doing that now. You need also to clone the Open3D repository and then to install the proper requirements of the Open3D. Then, what is very important in order to work with this repo, with this new modules, is to download a current small dataset of new scene. So in Open3D let's see that together. We have several ways to install different datasets. So the first one is here you can see in scripts, download datasets, and then we have the Kitty, we have Paris-Lille, Semantic 3D, Semantic Kitty, ShapeNet, and Toronto 3D, and others. So all these things you can download them by just executing the .sh. But again, I'm not sure that it would work because it's it's like 6 years ago, and so it's not for sure that the same dependencies are currently available. So what is currently working for me is to download this dataset, new scene. Okay, this is a current one. And in this dataset, so you can read that, okay, understand better what is exactly the content of this one. But here, I put all you need here. So this is the details of this dataset. So we have 1,000 of scenes and 40,000 images. The full version is about 350 gigabytes, and the mini version is about 4 gigabytes, and this is the version I used for the demo. Okay, to download this one, you just need to use this link. To use this one to download, in fact, the TGZ, the tar, the zip one, and then to extract all, and then you will get exactly this folder, sweep one. You will get also the samples, okay? This and this one are currently kind of same one, when the sweeps is like temporal data and the samples is other one. So you can see here that we have the LiDAR information. We have also photos in PNG of the camera, and we'll see what is the purpose of that. And also you need to have this one, v1.0 mini, and here we have all the JSON, and the JSON we are using them for indexing, in fact, the contents of the samples and sweeps. Okay, so let's go ahead and let's now execute our new module, the 10 cell LiDAR card detection. So to execute it, so again, let's do and activate Open3D. Let's do like that. And now Python, and then execute it. So let's now see what is the result of that. Okay, great. So now I'm going to visualize here a scene with the bounding box already annotated by the dataset. And you can see here, for example, this is a car inside. Inside the box, this is a car in point cloud, and we have detected this car using, not using an external model, but using the already annotated bounding box of the dataset. And the goal for sure is also to train in the future, to train a model. For example, we input the point cloud of a scene and output the detection bounding box of every single car from this scene. Okay, so what is interesting here is to see the trees, to see the lanes, to see the topology of the road, and also to see the car detection. Okay, let's continue. So now I can just close it. When closing it, here I can do enter to get the new scene, and now I have another scene here. This is also interesting. Okay, but let's see another one. Okay, here we see well the cars inside. Okay, let's see another one. Okay, this specific one because we have here the car without moving, you know, in the parking. So it's also another topology. You can see all the points corresponding to the millions of laser beams sent by the LiDAR. and we see now the car. Okay? What can be also very interesting is first to understand what is exactly what this code is doing. So new scene, as you can see, is import from the new sense here. So you can install this package as well. And to get this visualization, it's pretty simple. I just added like a rotation correction because I saw when I started visualizing this one, it was not in the good orientation. So it was necessary to add like a rotation of 90 degrees. So I did that and now it's working well. But beside that, it's very simple to get this visualization when we have the dataset as I explained before. Now let's see how to get in real time the camera video of this one. So now we need to execute the 11. Okay, so this is very interesting because you see in real time here the projection of the bounding box in the 2D camera, and we also see them in the LiDAR sense. So we have the indexing, it should be okay, and here we have also the depth bounding box. We can continue to see another scene. Okay, we have the detection of all the cars in the road, and we see in real time their movements. Okay, so that's it for this video. In the next video, we are going to see deeper in the code why it's working and how it's working exactly. What was great here together, it was to understand that Tesla and other companies are currently using the LiDAR system and other sensors. And the game changer for this company is to combine the sensing from camera, from LiDAR, in order to get the 3D perception. Thank you for listening to me. Share this video